This is the homework for 168, 169, 170, and 172, A, B, and D. Problem 168, we need to rewrite each expression. And we can do that in several ways. I'm going to show you two different ways, and the first is by expanding the expression and creating a giant 1. So h to the 11th can factor out to h to the 9th and h to the 2nd. When you're multiplying like bases, the exponents, you add them. 9 plus 2 is 11. And so here we have h to the 9th for the denominator multiplied by 1. Well, that's still h to the 9th, which we created a giant 1. So 1 multiplied by any number would be itself identity property of multiplication. So 1 multiplied by h to the 2nd over 1 is h to the 2nd, or h squared. The second way you can do this is the rule for simplifying exponents with the same base is you subtract the exponents. So if you have like bases, and the way I remember is the fraction bar is like a giant subtraction sign. So you keep the base, and then we have 11 minus 9 equals 2. Here we're multiplying, and we have the same bases, like we have like terms. And when you multiply, you keep the base, and you add the exponents. And the reason why is because x to the 3rd is x to the 3rd, x multiplied by itself 3 times, and x to the 4th is x multiplied by itself 4 times. So you have 3 x's and 4 x's. 3 plus 4 is x to the 7th. So I expanded it out, or you write it x to the 3rd plus x to the 4th. You add the exponent, and you get x to the 7th. 168c, here we have 3k to the 5th power raised all to the 2nd power. So the quantity of 3k to the 5th to the 2nd power. And parentheses, I always remember if I have something smashed up to a parenthesis or a grouping symbol, typically it means you're multiplying. But you have to multiply, you have to distribute that to all of the terms within the grouping symbols or parentheses. So here we have 3, and if there's no exponent there, you can put a placeholder of 1, because 3 to the 1st power is just 3. So I didn't change the value. And remember, when you have a power raised to a power, you're multiplying them. So 3 to the 1st multiplied by 2, 1 multiplied by 2 is 2. And then we distribute to the 2nd term. 5 multiplied by 2 is 10. 3 squared simplifies to 9. So we have 9k to the 10th. 168d, as I explained in the previous problem, if you don't have an exponent there, then as a placeholder, you can put a 1. And now when you're multiplying bases, like terms, you add the exponents. 7 plus 1 is 8, so we have n to the 8th. Keep the base, and then you add the exponents. Another way to look at this is n to the 7th. I have 7 n's. And n to the 1st, 1 n. Add all those n's together, n to the 8th. 168e, we're going to simplify this expression. And here we have 16 divided by 2. And there's one way you can do it is factor it out and create the giant 1. And so this creates 2 multiplied by 8 is 16. And there's our giant 1. 1 multiplied by 8 is 8. Or you can just 16 divided by 2 is 8. Here we have x to the 4th divided by x to the 4th. Well, that creates a giant 1. So these, anything multiplied by 1 is itself. So we can go ahead and eliminate that, those two terms. And then we are left with y to the 3rd, which we get 8y to the 3rd. The other, remember in a previous problem I said treat this like a big subtraction sign. So when you're dividing like terms, integer exponents with the same base, keep the base and you subtract. 4 minus 4 is 0. So those x to the 0 power, anything to the 0 power is 1. And then here we have y to the 3rd, and there's nothing to subtract, so we're left with y to the 3rd. Problem 168F. We're simplifying this expression, and we simplify by combining like terms. So we need to identify which terms are like terms. Well, if you have the same base, when you're multiplying, those are like terms. So we can combine, because all of these are multiplying. This is 4 multiplied by x multiplied by y to the 3rd multiplied by 7 multiplied by x to the 2nd and multiplied by y to the 3rd. So we can multiply these two because they have the same base. And remember, if you have a placeholder here, and when you're multiplying like terms, you keep the base and you add the exponents. So 1 multiplied 1 plus 2 is going to equal x to the 3rd. Here we have 4 multiplied by 7 is 28. And then here y to the 3rd, we have 3 y's and multiplied, and 3 more y's multiplied. So we add those together. 3 plus 3 is 6. If we were to expand this, it would be y multiplied by y multiplied by y. And same for that, and we'd have 6 y's being multiplied.